Hi, everyone. Welcome to Platforms as Contracts. My name is John Feminella. I'm a platform architect at Pivotal, so you won't be surprised to see the name platform in the title and in my title. What I want to talk about today is evaluating a tough technical choice that a lot of companies are faced with, and you're staring down the barrel of you've got a pool of applications. You want to run them in some way that makes sense for your organization. You probably want that model to be consistent. So you're probably looking at something that will help you decide what the right strategy is for how to run all those applications in a consistent way and make all the people who deploy and operate those applications happy. So that's a really hard problem. If you're the CTO or the CIO, or you're an application developer, or you're an operations person, that decision is going to impact you in some way. So what I want to talk about is a different kind of mental model for deciding how to make that choice. And I want to compare it to some of the models that we already talk about or that are typically used and describe how this is different and the advantages that it can bring. So really briefly about me, my name is John Feminella. You can follow me on Twitter, and then that's my website. If you have questions, by the way, during the talk, I would love if you could tweet them to me. So if you go to the Twitter handle is at the bottom of every slide. So if you've got questions, I want to make sure I get to them at some point. So after the talk, I'll make sure I reply to you, or we can sync up afterwards. So you're thinking about platforms. You're trying to figure out, you're the CIO, you're the CTO, you're a BIO maybe. You're trying to figure out some way to make all your business stakeholders happy, all your technical stakeholders happy, all your operations people happy, but you've also got a portfolio of 5,000 applications. Some are Java, some are C, some are legacy mainframe stuff. How do you wrangle all of that? I think it's best to start out by talking about what we mean, or what I mean when I say platform. And the sort of generic term of platform is something that connects suppliers and consumers of some good or service. So for example, you could argue that the World Wide Web is a platform because it connects people who want to serve websites with people who want to consume those websites. Similarly, you could argue that other kinds of exchanges or markets are platforms. So you might argue that Uber is a platform because it connects people who want to sell their time and their car space to people who want rides somewhere in exchange for money. And an application platform is exactly the same kind of model. It connects people who operate a platform, the operators, with people who want to write software that runs on that platform, people who want to deploy code to some location. So the job of the application platform, like any other platform, is to connect people who want to consume some good or service with people who can supply that good or service. So how do you decide to use a platform? I think that's an interesting question, but I think that the answers to that are usually pretty straightforward for any given organization. Usually you want to use a platform because you've discovered that whatever you're doing right now doesn't work. Your CEO is mad that you're not delivering software fast enough. Your customers are mad because they're not seeing changes happen. Your lead developer is mad because they have to go through 37 operations folks to make one software deployment, and you only get to do that once every 12 weeks. Like, those all suck. So the reasons of why you'd use a platform, I think, are for another topic. What I want to talk about is how do you evaluate a given platform? So you've decided to use a platform, but how do you know if one platform that you're considering is better or worse than another? And in order to consider that, I want to consider a slightly different question. So let's go back to our web analogy, where we have the World Wide Web being a platform in the sense of being a supplier and connecting suppliers and consumers of web pages or web content. So you've got a web server and a web client, and they want to communicate in some way. And the way that typically happens is that the client asks for some content. And both the client and the server do a protocol negotiation. They agree on how they're going to talk to each other in order to make the exchange happen. And so if you peek under the hood, you can see that they're conforming to the protocol because they exchange messages that comply with that. So in this case, the web client, that your laptop or your mobile phone, will say, hey, get me this URL, and I'm speaking HTTP 1.1, and I want to request a page from a host named example.com, and the server will respond with, yes, I have that content, here it is, and here's what the content looks like, and it's got these metadata fields attached to it, and here's the actual body of the content. So you wind up with a web page that says, hey, here's what you asked for, and I gave it to you. So why did all that work? Well, you could argue for some of the more boring reasons why it works. So you could sort of be pedantic and say, well, it worked because they both correctly implemented HTTP 1.1. That's a valid answer. They did both do that. It's not very interesting, though, because it doesn't explain why the transaction was successful. And you could argue that another sort of boring explanation is, well, it worked because all the DNS servers and the routers and switches in between the client and the server were correctly configured. Okay, that's also true, but not a very enlightening or interesting explanation. I think a more interesting explanation is that it worked because both people got what they wanted. So the person operating the server successfully sold someone a widget, or successfully told them about some content they wanted, or successfully showed them a bunch of ads. And the person who was the client got what they wanted. They asked for some web page, and they got that back. And notice that there are human beings on the other side of the technology there, right? So there is someone who asked for content, and there is someone who is willing to supply it. So I think that ultimately gets to the root of that there's something foundational about the fact that there are people behind these pieces of technology, not just pieces of software. And that means that if people are involved, then we can't be glib with answers like, oh, it worked because of the network protocol stack was correctly implemented, or all the configuration in between the two servers was fine. And that means that the answer about choosing a platform is also going to be somewhat hard. So we have to look at the people involved. We can't just sort of do a glib cost-benefit analysis and decide that platform A is better than platform B in all possible cases. But that's precisely what a lot of the strategies that people currently use to evaluate platforms consist of. So probably one of the most common is to do a sort of TCO, total cost of ownership analysis of a given platform. So you're deciding to replace, say, a bunch of servers that you manage with some Kubernetes or something running on AWS. Okay, that's cool. And then sometimes people will say, okay, well, the way I'm going to decide if that makes sense or not is to add up what it's costing me to run the servers in-house and all the people and all the licenses that are required for that, and that's one column. And then on the other column, I've got, okay, what am I going to get out of the Kubernetes approach or the insert flavor of the one tier platform? And those are really naive, really simplistic approaches. Like the value that you'll get out of adding up all the things in column A and subtracting all the things in column B is going to get you a number, but does that number have any meaning? Does it point to anything real in your organization, right? Okay, maybe you'll save $400,000 a year, but is anyone actually happier? Do people want to use this platform, or are you just forcing something down people's throats that isn't addressing an actual business problem or isn't addressing a real benefit? So I think the real question to ask here is the way you're choosing your platform and the choice that you wind up at, is that actually helping the people in your organization? Are developers happier about deploying? Are operators happier about not having to answer 4,000 tickets so that one piece of software can be deployed into an environment? Is your CEO happy because things are getting delivered to production faster and customers are seeing new stuff and they're buying more things, et cetera, et cetera? So the underlying bedrock here is, are we helping actual human beings regardless of the technology we're choosing? And so I think that motivates a different choice of evaluation strategy that's different from the ones I showed before. We can't do something like a naive cost-benefit analysis. That's not sufficient to describe what's actually happening when we decide to rip out everything and replace that with a platform, an application platform, I should say. So if you remember the web server, web client example, we saw that there is effectively an agreement between two parties to communicate. So we have a web server and a web client. And an agreement between two parties to do something is basically a contract. So if I agree to sell you my house for $400,000 or whatever, then you're agreeing to pay me $400,000 if you enter into that agreement. So we've conducted a transaction by virtue of the fact that we both wanted something out of some negotiation or arrangement, and then we both got that thing because we completed the arrangement. So that's precisely what a contract is. So what are the essential ingredients of a contract? So it turns out that if you ask anybody with a legal background, you'll find that there are, it depends on the country you're talking about, but in general, there are 3 special ingredients that go into a contract. First is that there is consideration for both parties. So consideration means that I get something and you get something. So it would not be an enforceable or a good contract if I made you sign something where I get something and you get nothing. That would not be a valid legal contract. The contract also has to be conscionable. So if that means that we both have to agree that what we were getting out of the contract was valuable for both of us. And so, for example, sometimes courts have held that terms of service contracts are not conscionable because they don't give you something that you really want. They just say, hey, you're going to use our site, that's fine, but we're going to get all this other stuff in exchange, and you get like a little bit. So that's called an unconscionable contract. If you are agreeing to something that if you knew what you were agreeing to, no reasonable person would sign it. So that would be an unconscionable contract. So we require that contracts be conscionable. And the third part is we require that contracts be entered into knowingly. Both parties have to understand what they're agreeing to. So both parties have to agree that the terms of the contract are things that they want to complete, and then the hope is that at the end, after the contract has been executed, that exchange happens and everybody leaves with something more than they had before. So those are the three pieces of what makes up a contract. So I think an interesting question to ask is, are you getting that from your platform? So if you've chosen a platform, are you getting the consideration that you wanted? Are you entering into an agreement that is conscionable? Are you getting something that's fair in exchange for what has to change about the way you push applications, or about the way that you write things, and so on, or about the processes that need to change, or the people's jobs that need to change, and so on? And finally, are you aware of and educated about all the things that will need to change for the contract to be effective? If you decide to start using some new technology, are you aware of like all of the things that are involved in changing to that technology? Are the people that will be affected by that aware of that too? Or is this a decision that someone is unilaterally making without consensus or without any real buy-in from the people that will ultimately have to do the work? So again, I think asking whether your platform is giving you something worth for what you're giving up is a valuable question. So one way to think about that is you can look at what your platform requires to deploy applications. So go through the mental exercise of how you deploy an application. So starting from the moment that someone has committed code to your source control repository, hopefully you have a source control repository, but assuming that someone has committed code to that location, that's the earliest that you could reasonably be expected to deploy it to an environment, right? So you commit on day 1, you could, right after that commit, push to production if you care to. Now, why don't people push to production immediately after every commit? Well, we introduce delays into the process because we expect to get something out of the delay, right? People just don't arbitrarily delay for no reason, right? So we usually have maybe a QA person is going to review the code, or somebody from auditing and compliance has to sign off on a new software release, or everything has to go through ops and they're required to actually do the deployment and so on. So we've introduced pieces of process that we believe are worth the trade-offs, or typically that's what organizations do. So it's worth asking, hey, is that trade-off actually worth it? So maybe that process was introduced 10 years ago and it's never really changed, and that's just the way people have always done it. So maybe it's time to reevaluate that. So, but the earliest you could deploy anything is right after you've committed it, right? So go through the mental exercise of what happens next in your organization or with your platform. So do you maybe talk to another human being to like file a ticket? Do you have to talk to a lot of people and all get their consensus that it's okay to release? So if you're an application developer, how much work do you have to do to actually move your code from one place to another? Remember, we're really just pushing electrons around, right? So it shouldn't be that hard to push electrons from one location to another, and yet we see cases where it takes companies 2 months, 3 months, 6 months to push to a production environment. That's kind of crazy. Like, how is it possible that it takes longer to push electrons than it does to ship oil across the Pacific Ocean? Like, there's a mismatch there. So looking at your platform through the lens of what do you have to do to actually push code onto your target environment through the platform is worth considering. So does something about your application have to change for all applications? Do you have to include like some magic file that your platform has to know about? Do you have to adjust the way that you write all of your applications? Is there some like interface that I'll have to comply with or conform to? And then is there a property or a set of properties your application for which it must be true for your application before you can deploy onto some environment? So those are the kinds of questions that you should be thinking about when you're evaluating the what am I giving up side of the equation. And then the flip side of this is, okay, well, you've given up a bunch of stuff. You have to do a bunch of work. And then what are you getting for that work? So are you getting guarantees of uptime and SLAs for reliability and so on? So what is the platform giving you in exchange for doing the hard work of whatever is required to deploy the, applications through that platform? And different things that call themselves platforms have different answers to this. But in general, we would expect a platform to do something for your application, right? Otherwise, it's kind of falling into the unconscionable territory, right? We want using the platform to have a very clear, specific benefit, and it's not really enough if that benefit is just we save a bunch of money or a sort of a line item on the budget. So it's really more about what benefits are you getting out of actually deploying applications that you weren't getting before? Are your applications more robust? Are they more resilient to different failure modes that they weren't before? Is the way that you deploy applications now consistent regardless of the kind of application you're deploying or the target environment you're deploying to? Are there things that your application doesn't have to do now that it did have to do before, or that your environments don't have to do now but they did have to do before because the platform is managing those things? Those are the kinds of questions you want to ask yourself from the giving perspective. So from the getting perspective, what are you getting out of the platform? And so you can imagine thinking about platforms in this way, where we have two axes. One represents we're getting more out of some contract from our application platform, and one represents where we're giving more out of our application platform, or giving more to our application platform. And if you think about the quadrants that these form, you can see that there's really only two acceptable places to be. Either you don't want to have an unconscionable contract where you're giving a lot, but you're not really getting very much. And it's not really possible to have contracts where you're giving almost nothing and getting a whole bunch. If that were true, then probably you're being sold some marketing hype instead of an actual application platform. And so the two places we can really occupy are small contracts that you don't really, platforms effectively that you don't really have to give up much for. So you get to do everything like you do it now, but you don't really get that much in exchange for it. Because remember, a platform doesn't know anything about your apps, not intrinsically. So if it has to run arbitrary code, and that arbitrary code doesn't have to change, then your platform probably can't make very strong guarantees or promises to you about how it will work. So for example, if your platform simply runs unmodified images or unmodified containers that you supply, you're probably not going to be able to get very strong guarantees out of it. You might be able to do things like, well, I'll make sure that n instances of X application are running all the time, but you probably won't be able to get other benefits like I'll be able to make sure that all these applications can talk to each other in the correct way, or I'll be able to isolate the applications from one another in a way that makes sense. So the kinds of benefits you can get when you're not giving up very much are somewhat weaker, because the platform itself doesn't know anything. It can't assume anything about your applications because you've made no effort to try to standardize or try to make sure that they comply with this new platform environment. And on the flip side, there's big contracts, or what I'm calling big contracts, where you have an application platform that asks a lot of you, or asks you to conform to something that's not simply an unmodified runtime image of whatever your application is, but rather is maybe some set of source code or some set of binaries that conform to a specification of some kind. So the bigger the contract, the more the application platform knows about the kind of applications that are running on it, the stronger the guarantees you can get. So if you're running, a business and you're choosing a platform, you probably want the platform that's going to give you very strong guarantees about how things will run, rather than the platform that can make almost no guarantees about the kind of thing that can run. And switching from the contracts mode of thought to the platforms mode of thought, we kind of wind up with a few distinct categorizations. So what I call platforms are things that are really in the upper right quadrant. So stuff where you give it an application, and by application I mean arbitrary blob of source code. And the arbitrary blob of source code is transformed into something that is then able to receive requests, execute instructions, et cetera, et cetera. I don't mean something that takes an unmodified machine image from an arbitrary location and then runs that unmodified machine image with some specification that you supply. So that's not a platform to me because it doesn't make very strong guarantees about the kind of things that can run on the platform and the kind of things and the kind of guarantees you'll get out of the platform. So conversely, there are things that are closer to the infrastructure side where you're taking some bare metal and you're putting an OS on it and you're running something on top of that OS that lets you run arbitrary source code. So that's a big benefit. If you're handed bare metal, you want some consistent way of putting those arbitrary machine image blobs onto the hardware. So that's a great case for where the things that I said weren't platforms would be useful. You want a consistent means of deploying and monitoring those applications. So those infrastructure-oriented platforms are very useful. They just can't give you the same kinds of benefits. They give you a different set of benefits than the application-oriented platforms. And there's sort of a category that's a little weirder, but I call augmented infrastructure. And there aren't a lot of examples of this, and they sort of were in the earlier days of when we were sort of figuring out exactly what the blurry line in between infrastructure as a service and platforms looked like. And I would say one that people may have heard of is something called TIBCO Silver Fabric. This basically allows you to run arbitrary machine images like Docker images or like existing applications, and then provides a way for those things to run on hardware that TIBCO Silver Fabric is monitoring. So it performs a really useful job of providing that sort of layer there, but then it also adds some like services on top of it that your applications might want to communicate with. And so it's sort of in an interesting spot in between the infrastructure and platforms side of the spectrum. So, and this is just my sort of arbitrary designation of where some of these things might live. Obviously, this should be taken with a massive grain of salt. A, because I'm employed by Pivotal, but then B, because this is a subjective description of where these things work. But I think most people would agree that bare metal hardware is probably not asking a lot of you and is not giving you a lot, so it should probably go in the bottom left part of the graph. And something like a Heroku, let's say, should probably be closer to the top right end of the graph. So something where your applications are, your platform is running your applications as unmodified source code, and you maybe have to agree to like have a 12-factor application, for example, or have your applications respond to signals like sigkill and so on, and agree to shut down gracefully and monitor their transactions and so on and so forth. So you have to do a lot more work for your applications to be on the platform, or you have to agree to a lot more. Maybe it's not necessarily more work, but you have to agree to behave a certain way. But then you get a lot more, right? Because things like Cloud Foundry will provide very strong guarantees for your applications that are running on the platform. So I think overall that this getting more versus giving more analysis, I think, is better for understanding how the people that will use your platform are going to experience it, right? If they have to change everything about what they're doing, then you'd better be pretty sure that the benefits you get out of it are strong ones, that the guarantees that the platform is going to make for you are strong ones. And conversely, if you're interested in a platform, it doesn't really require you to change much about the way you do anything. I think I would be suspicious of whether or not it's actually giving you that much benefit, right? So if someone comes to you and says, this is the best thing ever, use platform X, but then it turns out that to use platform X, you don't actually have to do any work, that's not that much benefit for you, right? Like the platform's not gonna be able to guarantee much about how your applications will run. So brief takeaways that I hope you get out of this talk. The mental models of how we evaluate platforms, cost basis analysis, things like that, are not sufficient, I think, to describe how people will use those platforms and how to accurately assess whether the platform will be a success in your organization. Doesn't do you any good if you save X thousand dollars per year, but then everyone hates the experience of using your platform, right? That sucks. What you'd instead want is a platform where everybody loves deploying and it's making your company a whole bunch of money and your CEO's happy and your CIO's happy, et cetera, et cetera. Then it's a win for everyone involved. So I wanted to encourage with this talk a consideration of the people and effort involved in adjusting your platform, not just the strict down the line cost-benefit analysis. Remember, no platform technology, doesn't matter what it is, can be considered a panacea. It's never about picking the magic technology that will solve all your problems. Such a thing doesn't exist. Anybody who tells you that it does is lying to you. So it's ultimately about the people that are involved in using the platform and maintaining the platform and in deploying to the platform. So thanks very much. If you have questions, I would love if you could tweet them to me so I can respond afterwards and make sure I have a chance to address everything. Thanks so much.